glucose in which you add the heat of formation, since unisynthettic glucose does not include this heat of formation.
Oh my goodness, that was a lot.
Then also you need to make sure you have heat of formation for cellulose, that's easy to find. Hemicellulose, if you cannot find it, other glucose enzymes. And the main job that you're doing is designing your separations, your actual separations. And as a first step, I didn't put it down, but as a first step, what you probably want to do is replace your component splitter with multiple component splitters, each one representing one particular unit. So if you have to use three distillation columns, you put three component splitters saying what each distillation column will be. Clear? All right. And if you're going to be using an entrainer, find experimental data for it and select parameters on the basis of matching experimental data. Okay, so here is how I recommend that you proceed for the next step. You don't want to take the component splitter and replace it with a distillation column. Getting distillation columns to converge, if you have isotopes and things like that, it's a pretty challenging task. So you don't want to couple that with recycles, fighting to get convergence and adjust and everything else that you have. So what you want to do is take the feed to the component splitter that is going to be replaced by a distillation column. And get that, put the distillation column on that feed and make that conversion. Now I'm saying getting the feed. You can't use clone or Control-C, Control-V because those don't preserve anything that is calculated, only the things that you specify. So to get an accurate copy of the feed to the component splitter, you should create the material stream, and in the first stream, there's something at the bottom that says define from other stream. And you define that from the feed to the component splitter. So now you have the feed separate, and you build just isolated your distillation column. You get your distillation column to converge as you want. Make a copy of the converged distillation column. And now we're going to do the replacement. Maybe not a very good analogy, but I can't resist mentioning it. Think of heart surgery. First, what do? Anesthesia for the patient. What's anesthesia here? Red light. Okay? Then you remove the old heart, you take out the component splitter. You put the converged distillation column, reconnect everything, and then you awaken the patient with the green light. Now, one complication that could be happening here. Oh, sorry, I forgot something very important. Let me go back. Okay. Before you do the surgery, you need to go back. Yes, I just killed the patient. And it's good that I'm not a medical doctor. That's really good. I hope my sons are going to be very good doctors. I have 3 sons that are in medical schools. Wow. Anyway, so I forgot to say a very critical thing. After you have converted your distillation column, what you get out of the distillation column is not going to be the perfect split that you had in your component splitter. So before you do the surgery, you want to modify your component splitter to match what you got from the distillation column. So you need to change the component splitter slow so that you maintain convergence to have effluence what you actually got from your distillation column. Now there's a complication here. That the changing the effluence of the component splitter because of recycles may actually affect the feed of the component splitter. In which case, if it's just a little bit of a change, probably you're fine. But if it's a significant change, you need to go back and redo the distillation column with a new feed to the component splitter. And repeat until you feel you're close enough. And then you do the surgery. Okay? So that's the process that we need to use. And finally, the last bullet, if you envision using liquid-liquid equilibria, check the suitability of your parameters, not of V parameters. For the pertinent binary pairs by checking solubilities. If not satisfactory, check the suitability of Unison LLE, or if there's an LLE option in us. Clear? Okay, so any questions from the 200 proof team? Oh yeah.
If we come up with multiple ways to separate it, should we try to model all of them, or two options and then see which one is more feasible?
You can. The costing will be coming later, but
so we shouldn't consider cost when we are splitting.
Well,
using one or
it takes a lot of work to consider cost.
Okay.
Because what you have to have first the whole thing designed with all the flows. That will size the equipment, diameter of columns and things like that, and only then you can get cost.
Right.
So,
right.
And we're not ready for doing that yet.
Okay.
We haven't done the exercises for sizing equipment and things like that. I haven't even published instructions for that.
Okay.
So that's the Liverbus 1011, we're talking about that. But if you have a second method, you may want, there's 6 or 7 members to each team, you may want to look into that also and keep it as a backup, proceed with the one you like best and keep the other one as a backup in case that you find out, well, the cost is terrible for this one, maybe we'll do better if we take the other one. No?
We are trying to fully model however many components we have in total, right? Not just one.
Yeah. No, what I'm saying here, and actually I should have pointed that out, the statement is for both simulations, devise separation strategies for replacing each component splitter. You have freedom in designing prototype, but what is it? What can I say that you have to try to get the first one? Okay, here we go. Start modeling in Unison the replacement of the first component splitter of each process. You are not required to achieve convergence. So when I say you're not required to achieve convergence, that means that you can still get a 90 score if you haven't achieved convergence, but you have done a good job in everything else. Obviously, you can get a lot higher if you have achieved convergence, and if you have achieved convergence of several units, the better your grade will be. Also, some of your units will be very easy, not tough at all to converge. And if you want to separate a highly volatile gas from liquid, probably you don't have to use a distillation column. Probably you can just use a flash unit, which is basically just a unit that provides residence time and what do you call it? You have in the construction pieces that allow for liquid that is carried with the gas to condense again, so to minimize entrainment. It's not a column, it doesn't have reboiler, it doesn't have condenser, it just provides residence time for vapor-liquid separation and has a design that allows surfaces for liquid that would normally be carried with the vapor to recondense, so you don't carry significant amount of liquid together with the vapor, because that's the bad thing. That's called entrainment.
An ambient
Buffing.
reflux.
That's what I wanted to say. The word I was looking for is buffing. It has internal baffles. So there are proprietary designs, etc. for that. So this is a flash unit. You don't put any energy. It's an adiabatic. You can put energy, actually. You can change the temperature if you want to for the flash unit. It's the separator in Unison, not the three-phase separator that we have for the decanter. What they call separators are, and you have the option of an energy stream. If you want to heat it up some, you can. If you want to cool it up some, you can. Okay, but that is easy if you have a highly volatile, because distillation will give you better separation, but you would have to do cryogenic cooling in some cases to try to do that, because remember, if you use distillation, you have to condense the reflux. You don't have to condense the distillate, you have to condense the reflux. Yeah.
For the bioethanol plant, at the end, do we want to separate ethanol only, or are we also concerned with separating everything else?
You may want to separate other useful products if you can sell them, because otherwise, if you have organics, etc., you may even have hazardous waste.
Yeah, that's what I was thinking. Like, I don't know if that would be like a safety issue. Like,
yeah, and part actually of the things that I want you to document, or put it better on deliverable 9, is a full safety analysis of your final design. I want you to list for every component that you have the autoignition temperature. Make sure that your temperatures are below the autoignition temperature. Make sure that there's no situation between upper and low flammability limits if there's something like oxygen present or something like that. Make sure that you find out the regulations of what concentrations can be disposed and how. So basically find the environmental regulations also. And this is something that I was not doing in past design classes, but I got a warning that one of the things that ABET, you should know guys that your reports are going to be scrutinized like never before, because your reports are going to be examined by ABET evaluators for accreditation. So I'm adding definitely some that they call standards and some that they're looking for, or standards we don't have, but constraints. So if you pay attention to the safety and the environmental constraints, so that would be added thing for your teams. Okay.
All right.
Any other from your team? Have a good night and time to present. I think I need to plug my laptop in because I'm almost out of power. Although, are you going to be, do you prefer to hook up your computer or do you have a USB drive? What do you prefer to do? Here. Okay, then I can just
Yay. So much fun.
So we already talked about what is next week. Oh, you have any questions about next week?
No.
Not you, Shayla, you already had it?
okay.
Is everything clear about next week?
Yeah.
Then we're done with next week's deliverable. And we talked about what you did.
So, my only.
So Bartholomew, you're doing that on us? Yeah. Okay, so stay behind the.
No.
You want to move on this side?
I do.
Yeah, you want to move on this side, please?
Oh, okay.
Oh, the presenter?
Where's the presenter? Good. Where you are is good. This projector, unfortunately, I cannot project anymore on this wall because this screen totally absorbs light.
Oh, wow.
And it's not powered yet. We'll be able to use it in the near future, I hope. The only other place I could possibly put the projector is there, but there are no outlets close here.
That's fine.
And that projector is a very bright light. And last week, I accidentally looked at it a couple of times, and my eyes were hurting for something like 15 minutes, 20 minutes afterwards.
If you need to stay.
So if you value your eyes, I want you to stay behind so you don't accidentally look at this very bright light of the projector.
Okay, probably won't be going through this and then we'll.
That's why I want you to stay behind there so you cannot accidentally. You have this pointer, okay? You bet. So you can stay further back. You can move this chair so you can plenty of space to face on this side. The only person on this side.
Or are you going to be clicking?
This is not good. Now someone needs to sit here and change the slide.
Right.
This is only. This is only.
Oh, this is the pointer, right?
Come on, this is a $5 thing that is being sold for pets. This is being sold for cats to follow laser light. I haven't told you why I bought this.
I think you told us
Yeah, you told
2
us.
weeks ago. It was the only pointer available.
Well, no, it wasn't. I could find a $40 pointer.
It's
In the Federal Express store, they had $40 pointers. Well, I didn't want to spend $40 for a pointer. So I went to Target, do you have any pointers? They said no, but then the person said, wait a minute, we may have something you can use. I said, okay, it's in the pencil. I said, what?
You should have gotten one of those like $300 laser pointers that'll like burn your eyes if you look at them.
Yeah, the ones that are illegal to point into the sky because it'll derail planes.
What? I didn't know that.
And these were supposed to be funny.
Well, not that they derail planes, but like that they make something so like obnoxiously overpowered.
Okay. This is my chair if you don't mind.
Yeah, no, I don't mind. You were sitting there, so I'm like, oh.
Well, I was sitting there because my computer was until I was taking it and I was projecting
Oh, okay, yeah.
and discussing it. I'm sitting as far away as I can because part of what I'm looking is if you're talking loudly enough.
I thought you were worried for like the spit.
Alright, Bartholomew is doing the honors. Let me write Bartholomew here. Check the spelling of Bartholomew's line. Okay, I was spelling it good. Now, the Y, is it on the laptop?
Yeah.
The Y is problematic. Jiggle the HDMI wire,
Like on our end or on the end of the
the
projector?
whole thing.
Okay.
And you may want to plug it and unplug it a few times.
Well, that's exciting.
Yeah. I had to fumble with it about 10 different times until I got it to work on my computer every time I disconnected it. There you go. You got it.
Oh, jeez. Oh, no. I think I accidentally hit, like, the space bar 20 times, so it created extra slides.
Control Z.
Oh, yeah.
Magic Control Z. Whoever invented Control Z. That guy was smart. Absolutely needed. Oh, I forgot the first thing we need to do. Sorry. Return your last week's report. So, well written. Good job on the Unison simulation. Adequate literature review. That means your literature review could be better. 92. So,
Do we get,
yeah, you're kind of minimal, that's fine. So on your adjust, okay, yeah, actually I did have a question here. So your adjust is fixing the ethylene, but how do you ensure, so one thing I don't know if you did, and probably you didn't, probably you didn't have the right amount on the
Also, this adjust,
reactor.
this adjust is making sure that,
You have the 300 million pounds.
and
Right.
it was making sure that our literature said ethylene and steam ratio needs to be 1 to 0.6, and this adjust makes sure that that ratio is maintained by control.
So how do you make sure that you got 300 million pounds a year?
Well, I already said how much ethylene was coming in.
Or you calculate it?
Yeah, I calculated. Didn't we include the table? Yeah.
So you calculate by hand,
Yeah, I calculated by hand.
Oh,
And I
okay.
made sure the ratio is 6 to 1.
Okay.
That's-
Yeah.
that's
Well,
just
okay,
that.
that was
Yeah.
that. Okay. So that was to fix the ethylene. So you fix the
Face down,
steam.
face down.
So you have the steam fixed
Yeah.
to make the
Yeah.
proper amount. Because normally. So what's the ratio you're supposed to have?
1 to
0.6 to 1.
0.6.
Yeah.
One ethylene.
Oh, ethylene is in excess, not the other way around. Oh, most teams have this process have steam in excess of ethylene.
Are they recycling that?
Yeah, the ethylene is the one that's being recycled.
No, but in your case you have steam ethylene excess. Okay, that's what I was. Yeah, so what's right? So you had this thing fixed, and that was what was wondering because if you fix something, you normally fix the limiting reactor. And I was expecting that you fix ethylene and adjust steam to have the ratio, but no, what you did is correct with the ratios that you know. Okay.
Had that been marked against us? Or
Not
was it
really.
just a
Not
coincidence?
really. Not really.
And then, did you? Oh, okay. We've got the
Yeah,
rest
just
of the
pretty
replies.
landscape. Yeah, that's all.
And did Mithray have a chance to come and speak with you about our updated deliverable 3?
No.
Okay, because before deliverable 4, you had asked us to make updates to deliverable 3 and resubmit them.
No, you don't resubmit them. You submit. Okay, guys, that should have been part of deliverable 4. The corrections from previous go with the next deliverable.
We turned them in all at the same time, but and obviously all of our stuff is more up to date since we fixed deliverable 3 stuff. But there were specific items that needed edits
from deliverable 3, like our.
Yeah, that should have been here with the deliverable 4 report.
Okay.
Okay. Well, yeah, we'll do that for next time. Last week we did turn in like a really new.
Because you'll get some extra credit for the makeup work that you did.
Yeah, because we just submitted all of deliverable.
So you
3
gave it
again.
to Frey, not to me?
Yeah.
I'm afraid it's a little behind. I haven't yet started presenting.
They have not started to present. Okay.
No.
Can I be here?
Absolutely. Sit on this side because I don't want you to hurt your eyes. Yeah. There's a very bright light there.
Our futures have to do our futures of that, right?
Yeah, I have that deliverable 3.
Okay, so they should always have the corrections with the next deliverable as an appendix, and we give them a few points.
Yes. So
In the
you
next
remember
deliverable
how
4.
I came and told you that day that they gave me a new deliverable
Yeah,
and I would regrade it completely and give it back?
Okay, if you did that, that's fine.
Okay.
Yeah, okay.
Yeah, I'm not giving it back. I will give it
Okay, that's fine. Okay. Okay, then you can get it credit back this way. Okay.
Great. Okay.
Okay. But normally corrections go as part of the next deliverable.
Okay, yeah, and this
So
one.
this deliverable, the first thing we did, we fixed this was wrong with our previous work.
Right.
And now here's our new work.
Gotcha.
Because this is supposed to be every time your weekly progress.
Right.
So you have the new things you have to address, but if you have things left from the past that need correction, now is when you put them.
Gotcha.
Okay.
All right. Sounds good.
Good to go.
Oh no, we got the laptop.
Bartholomew is doing the honors. Okay, and I'll everything that way. If I get the new ones. Where's the new report, guys? Okay, no, that's the problem. Where's the new report? Oh, already put it here. So if you want to change it, go.
No, I need to ask you a few things first.
Okay.
Yes.
Did you find it? My ride.
Yes, I did.
So,
All right. Let Bartholomew start.
Dr. Swarovski,
Yes.
I was being picked up and my ride arrived 5 minutes ago.
Okay, go.
So,
That's
is that all right? I'm sorry.
Well done.
So you're the last thing you may sometimes be late.
Yeah. I mean, I can
Go,
stick
Brian,
around.
go.
Okay.
Go, you have someone waiting. Go. Oh! Wait, I changed my mind, Brian.
It's you. Octasio, do you mind if we use your?
You can tell me that, Brian.
I'm sorry.
Yeah, PowerPoints they don't have to have the back because PowerPoints they're still going to have the final report, but they won't have any feedback from us. But of course,
Why don't you give me a call and let me know? Yes.
Yeah.
And any talking points, make notes for me. Thank you.
Take care.
Mine requires a special HDMI.
Same as your own.
You're good on it?
I'm afraid some reports are kind of.
I have a binder. There's
You have an
somebody
extra
who
binder?
gave a binder.
Hmm?
The report had binder.
Oh, we were discussing it earlier. Mom brought up an idea. Would you guys prefer that our reports stay in paper format, or like could we present it in a folder? Or would you prefer to just be a stack of paper?
Well,
Like a folder or
something
anything?
like that is fine.
Doesn't really matter.
Something like that is fine.
Wow.
That's one ring.
That's wonderful.
Yes, I have.
So, do you get to keep the binder? Or do you have to give that back?
Giving it back.
You get the reports back, so you can get it back the way you get it.
Just staple the report back and hand it back like that.
Should have been. I think you
I
Brian.
don't need any more of that.
Yeah.
Okay. Let's go.
So my name is Bartholomew, and with the nice of that, I'm presenting the level 5. So what we did was, for this week, we fixed a few things in the bioethanol production, and there was no fixations for like nothing to do with the chemical production was good. Then the next thing we did was the binary coefficient, so aspen, leucine, acetic acid, ethanol, and water to make a diagram. Then we did our verifications between aspen and leucine. So for the bioethanol production, we didn't have the 300 million pounds earlier, so we fixed that to produce 300 million pounds a year, and that's the only fixation we did. Nothing else was fixed. It works well if you do the simulation. It works well. Then for the binary coefficients, we collected a lot of data for this. We were trying to find which of the models match our experimental data. We found experimental data for all ethanol, water, ethanol, ethylene, dimethyl ether, because dimethyl ether is produced in the reverse reaction of this. And all of that we used Unison default, that's the reset, and the Unison VLA. We put in the Aspen to generate this graph. Then we use the Aspen energy, and 4 different things to compare to the experimental data. From this, the worst one was the Unison VLE. You could see it shows like the asymptotes are over there, but it shows like the two-phase. I mean, the two of them doesn't really match what the experimental data shows us. So it was the worst one for this TXY diagram. We did more further verification to really know if that was the right parameter we needed for Unison and Aspen. So we collect more data for ethanol, dimethyl ether, and we plotted the experimental data, which is this on the left, and the Unison. So the black one is the experimental data we plotted. Then the orange is Unison VLE, that's Unison HLC, Aspen HLC. So from this graph, the best thing was the Aspen RK, VLE RK, and the Aspen HLC. So there was no way we could differentiate between the Aspen HLC and the Unison, the Aspen RK. So that really shows. So do you go to the next slide? So after doing that, we had to verify by again doing more XY diagrams for ethanol and water, and we still found that the Unison VLE was the worst one after transposing Unison coefficients on Aspen. So the Unison one still performed poorly compared to the rest. So the best ones we found was RK, Aspen RK, and Aspen HLC for the modules. So you can see this is the behavior by two-phase region. To like compare to normally it's something like that. Another comparison we did to make sure the data was really perfect. We did the same thing with our ethanol XY to verify our data where we transport Unison coefficients in Aspen and Aspen coefficients in Unison to generate this graph. Still, the RK was the best, and the HSC were the best. The two Unison ones were terrible. Then we did a ternary diagram for acetic acid, water, and ethanol. As you could see, this is the distillation boundary for that. The asymptotic temperatures there. There's no two-phase diagram for acetic acid, water, and ethanol for this case. And this is very important because next time it's this producing the bio reaction. Then to verify we did our calculations right on Aspen and Unison, we have to do the decanter problem. From decanter problem, we used the unison default parameters, coefficients to put in ISPAN and verify if the decanter, the three-phase separation is actually there. So on the right side is, as you can see from this is liquid, this is liquid, this is light liquid, that's heavy liquid. On the heavy liquid is 0.52 on unison, then on the other side is 0.59. That's pretty accurate compared to what we're expecting. Then 0.93, 0.309, this was 0.305. So transpose it right and was pretty accurate using unison and ISPAN to verify our information. If you go down, this is a table summarizing how the coefficient, the composition, the mass composition is unison and the mass composition is ISPAN after doing the decanter problem. 0.903 this side, 0.9805. So not too far from ISPAN and unison, so which is pretty accurate.
Should be close.
It's pretty close, yeah.
No, it's not. It should be close.
Should be closer. 0.6, this is 0.6, 0.09. I mean, that's the best we could get from this. We use the unison default and the reset one, put it on ISPAN, and that's the one that generated the entire thing.
I'm wondering if you have the envelopes at the right temperature. That's the one.
I think maybe the issue might have been, is there a way to display the component mass fraction on ISPAN?
Yes, you can choose mass or mole fraction.
No, I could do it, but like to display like the
specific,
the mass composition for benzene is
Because
this.
You can
I have to like
you can specify points.
like at that point there,
Yeah, you can specify
we
points.
might have just read it wrong. But that's
Yeah, like what I'm saying is like at the boundary.
No, what ideally you want to do is what I did in class. Put points, you put a point for the fit, put also points for the compositions that Unison gave you for both the heavy liquid and the light liquid.
Or like put unison.
you just
Yes.
we're just reading from here.
So you put points from what Unison gave you, add points here.
Like for us, like we put the feed in, but the problem is
Yeah, you should
we have
put
to,
the
like,
other two also.
I know.
Yeah, put the other two also.
Yeah,
I
that-
think it was
that's-
the fit, yeah.
Yeah, we're just reading this.
Yeah, so that's what I'm saying. That would show more accurate if it's closer because
Yeah.
you could easily misread it hard when you hover with the
Yeah.
cursor. Yes. And the other thing, if it's small changes, it could be incorrect temperature or incorrect pressure. Make sure you have the right temperature and pressure. And the temperature is a real challenge. Because it's very quirky. I don't call it the bind on this. Okay, so is it ready?
That's it for this presentation.
Okay. Feedback, Randy, you want to start?
Yeah. I feel like you could have known the phase diagram stuff a lot better, or you could have been more comfortable with it.
Yeah.
I feel like you should have touched up on like why some of them were bad, specifically like where it separates into two phases. That for me was like a big reason of why these like the unison models were bad. You were also looking at the presentation a lot. You should have faced us a little bit more.
There's so many diagrams, so I was focusing on the diagrams.
Yeah.
I mean, diagrams he has to kind of do what he was doing.
But other than that, everything else looked good.
Thank you. Your hand gestures were pretty good, but sometimes you were like the eye contact. I feel like you could have made a little bit better eye contact, and you made like a few more than a few like alone where you just got stuck. But other than just like looking at transitions, I thought it was really good.
That's
Most of that has been said. Just having like eye contact, like you try to distribute eye contact less, but having like more eye contact with the audience would have been a little bit better. And the main point I wanted to give you is just like being concise, like giving like a lot of information, like with few words would have been nice. Just focusing on these are the two main coefficients we got from Aspen. These are the best one, just highlighting on those instead of like going like on the ones that we don't need. So other than that, overall you're knowledgeable about the subjects and the deliverables, so it was pretty good.
I think you definitely deserve some credit for it because it's a pretty hard presentation to do because it's all graphs and like that where there's 5 different lines and you have to individually. So it's a tough presentation to do and definitely tough to keep the audience involved. So I would say the biggest thing that would work for me is the transitions between like each individual thing. Like whenever we went from one graph to the next, and then we switched completely to a different concept of this is a turn area diagram, which is almost semi-unrelated to the rest of it. So yeah, just the transition between, all right, finished with this idea, now we're moving on to the next idea, which is turn area diagrams. And then kind of giving everyone a chance to refresh, kind of like snap out of like deep investment in a graph with a bunch of lines.
Okay, you want to overall, you did a good job, all of you. You speak well, good pace. As people mentioned, particularly, actually, you had pretty good eye contact at the beginning when you didn't have to point. So I think eye contact, mostly you're fine. 2 things, arms as we have a lot of, we need to make an effort to reduce them. And the second thing, you had a tendency to sway a bit. And something you can do to try to minimize that. Now it's hard to do it in this room, but if you have something you can hold on, kind of anchor yourself. If you have a podium, you can hold the podium. But so that's something that is a little bit distracting. So you have to try to minimize. But all the fundamentals are good. Base is good. Talk well. Obviously, when you talk about all the diagrams, you're not reading or anything like that. So, good.
Be confident, you know. Yeah.
I guess. And I didn't give you back the previous report.
Not yet.
Did I mention the grade?
You talked about it.
Okay, all right. So it is. And I guess this was the problem.
And I will give you a 3 on Wednesday.
Okay.
Okay.